Hey guys, welcome to the official slash unofficial unit or topic three, class three. I mentioned this in class today. This would be Thursday the 28th, but my recording didn't really work out for the third class on Tuesday. Um, what happened was I hit pause record once I got or asked the class to do a practice problem, and I forgot to hit record again. So I'm re-recording this topic without any students. This means it'll go a little quicker, but I'm hoping to cover or redo everything I did in that class. So this will be a little different than my previous recordings because it's only me, but this is my second time working through these problems, so hopefully it will be pretty smooth. So this topic three, is about units of measurement, but more specifically, we're going to look at unit conversion. This is a topic for any student at the college. It could be medical science, IT, business, engineering. You're going to deal with numbers and units. A unit is kind of what describes what a number is. So, like any number or any measurement, we would call it in science. Unit of measurement. Let me get my drawing tool here. Sorry. So, when we talk about measurement, it actually comes with three parts, really. There's the number, which has a magnitude, like a size. There's the unit, where we look at, what are we actually measuring? And in Math 1700, we typically look at three types of measurement, which I'll talk about in a minute. And then there's also the concept of error, the precision of your measurement, and any error involved. But that's not for math. So when we measure something, when we write a number, it typically has a magnitude, which would be the size. 100, decimal 0.0005. These are kind of the size of the number. And then it would have a unit, a meter, a gram, a liter. These are common measurements that you will use in everyday life. You'll use at the college here, depending on your program. These are what we would call SI units in the metric system. So a little disclaimer for my, IT or business crowd. You will be typically dealing with dollars, cents, reals, different types of currency. For medical science, engineering, you'll be dealing with, meters, grams, liters, things like volts and amps and all sorts of different units. In math, we're going to keep it simple. So we'll look at length, mass, and volume, meters, grams, and liters. Any of my students who cook or spend time in the kitchen, you would have used mass. It could be grams or ounces, and volume, which could be, liters, milliliters, cups, also ounces. There's like a weight ounce and then a fluid ounce. So we'll kind of talk about all of these things. We're going to start with the metric system. The metric system is hundreds of years old. It was developed in Europe, but it's used worldwide. It says much of the world. It's everywhere in the world. The Americans are the primary country that differs, and they use what's called the imperial system. However, many of the American scientific community, or much of the American scientific communities, colleges, universities, would use metric. So like NASA, for example, uses the metric system. Some countries use a mix of the metric system and imperial. I know I mentioned this in the class, I think today. Canada is a prime example of a mixture where we use grams and kilograms. We use kilometers per hour for, speed limits. But a little bit of the imperial system, the American system, I'll call it, creeps in. If you ask the Canadian their height, they would use feet and inches, not centimeters or meters. If you ask a Canadian their weight, they might use pounds instead of kilograms. And I find here in the Middle East, in Qatar, that's a little different. This country is almost exclusively metric, which is fantastic. It's a worldwide system. The system itself, the metric system, uses what's called the International System of Units, or the SI system. So take a moment and think about that. SI system, international system. Why is it called that? Well, it stems from the French word or French phrase system international, which means in English international system. So we're going to look at this. A little disclaimer, its intercession time is tight, and we're going to focus on some of the more common prefixes, which I'll explain what that is in a minute, in the metric system. We're going to look at prefixes that you would use most often. I've been a science educator. I was a science student at university for years. I didn't really use a lot of hecto, deca, or deci prefixes. But most of you have probably heard of the kilogram or kilometer or kilometer, the centimeter or the millimeter or milligram. I get my pharmacy or med science students might deal with milligrams. My engineering students might deal with kilograms. A prefix is, in simple words, the word or the letters that go before something. Pre meaning before. Think of a movie. A prequel is a movie that happens before the main story. A prefix is the word that appears before the base unit. So you could have a kilometer or a kilometer or a kilogram or a milligram. So the prefix tells you or gives you information about the size or magnitude of that number. And before I get into the prefixes, we need to consider the base unit, kind of like the starting point for our 3 units of choice, the mass, volume, and length. The base unit, that's what this U stands for, and I'll explain what this line means in a minute. This is kind of like a unit conversion guide. In the middle is our base unit, and our base unit is the meter, the liter, and the gram. There are other base units. There's moles and lumens, I think would be another SI unit. Seconds or time, or the concept of time, we use seconds. These are all base units. We'll talk a little bit about time later. And I encourage my business students in here, so IT, business, to really focus or pay attention when I talk about time, because there's not many programs at this college that do not talk about time conversion. You might have to convert something from hours to days, days to weeks, things like that. So just again, a little disclaimer, we're going to focus on kilo, centi, and milli, which on this little guide, and I'm going to show you how to use this in a few minutes, they're towards the end. Again, in my 36 years of life, I haven't heard of hecto, deca, or deci very much. So a kilo, the prefix kilo means 1,000. So a kilometer or kilometer is how I say it. It means 1 kilometer is equivalent to 1,000 meters. 1,000 being 10 to the power of 3. This is the beauty of the metric system, by the way. All of these prefixes, the sizes of our units are all multiples of 10, which makes life easy, because instead of using complicated conversion factors, changing from like pounds to grams, it's not a nice number like 10. So the metric system's a little bit more efficient. It's certainly easier to remember than the imperial system. Centi. Now, centi and milli are less than the base unit. What I mean is they're smaller. So a centiliter or a centimeter is 1/100th of a liter. So you could divide it by 100 to figure out the liters. A milligram or a milliliter or a millimeter is 1/1000th of a gram. So this is 10 to the -2. This is 10 to the -3. We're actually going to talk and I've already did this, so I'm kind of speaking like back in time right now, but we're going to talk about exponents a little later. So yeah, as in on Wednesday's class, which I've actually already taught. So if you're not sure what I mean by 10 to the 3 or 10 to the -2, don't worry. It won't really impact this class. So how do we do these conversions? Well, there's two ways. You can do this mathematically using the numbers that I have above. Excuse me. So we're going to come back to these numbers here, 1,000, 100, 1,000. Or you can just use the unit conversion line or guide or image, diagram. I don't know what to call it. My gut says to call it a number line, but it's not really a number line. It's a unit conversion guide. So to go from a smaller unit, I'm here, to go from a smaller unit to something much larger. So, maybe I want to go from centimeters to meters or centimeters to kilometers. We're going to move the decimal place left or divide by the factor. Now, let me explain this. Imagine again, I'm asking you to convert the centimeter, which is here, to the meter. Well, I'm asking you to go backwards 2 decimal places or divide by 100. I'm asking you to go left on the line. So we go left with our decimals or we divide our number. So smaller to larger, you're dividing or moving left. So what about going from a larger unit? Like maybe I want to convert from kilometers to meters. Well, I'm going from something large like a kilometer to something smaller like a meter. So I'm going this way. Sorry. 1, 2, 3. 3 decimal places to the right now. And why right? Well, because I counted or moved the decimal or I moved my line right. In this situation, you would multiply. So converting from kilometers to meters, we would actually make the number bigger, right? In 1 kilometer, there's 1,000 meters. In 2 kilometers, there's 2,000 meters. So even though we're going to a smaller unit, the number itself will get bigger. And I hope that makes sense. And, I've said this before, the key for topic, I think this is topic 3. Yeah, is practice. You need to practice this. Honestly, between us and YouTube and the rest of the world, I guess, that can listen to this, a lot of the conversions I do, I would just use Google. I could go to Google and say 106 kilometers into centimeters or kilometers into centimeters, and Google will do that for you. So again, because this is such a common thing and you can use Google or an app for this, we're going to keep it pretty simple in this course, but it is a very useful topic, I guess, to know for any type of course. So let's look at a couple of examples here. Now, again, I know this is different because there's no students here. So I'll do this a little differently. I'll go through these examples and then we'll do a couple practice and I'll move on. I might go a little quicker than normal here because there's nobody to talk to me. I'm all alone. But if you guys, if anybody's listening and you have questions on this, check this recording, check the previous recording, come to my office hours, send me an email. I've had lots of questions about converting, and I'm willing to answer any of them. Okay, so let's look at these questions. All right, so, I said we wouldn't really focus too much on decimeters, but I mean, this is a good practice because the method is the same regarding, or irregardless, meaning doesn't matter how I'm doing the conversion, it's the same method. So It says convert 56.3 decimeters to millimeters. So what you need to do is place your pencil on the unit you're dealing with. So, I mean, this could be kilometers or meters, but in this example, it's decimeters. And it says count the number of spaces to go to millimeters or to go to the unit you're looking for, or more specifically, the prefix you're looking for. The unit is meters. The prefix is going from deci to millimeters or milli. So I would count. Now, this is, I wouldn't do my line like this. I would go 1, 2. So I am moving my decimal 2 places to the right. Keep in mind, I'm going in this direction. So 50, and again, these are not really placed very well. None of this is really, the book could use some work, let's say, but the idea is let me write it on the bottom, 56.3. I'm going 1, 2. Now this space here where there's nothing, I'm going to put a 0. Okay, so anytime you run out of space, add a 0. This means if you're going left or right, it doesn't matter. If there's an empty space, so let me do that again. So here's my decimal, 1, 2. If there's an empty space, 0. Okay, and now my new decimal goes at the end. So I can write that as 5630. I don't need to put the decimal there. I think a student the other day asked if they needed to put a decimal. No, not for this example. Now, the other way you could do this is because I move 2 spaces to the right, I can multiply this by 10 and 10. 10 and 10 is 100. So I could multiply this number by 100. And we will look at both of these methods. It's whatever you're comfortable with. I think traditionally I'm a multiply type of person. I know in chemistry, and I'm sorry for bringing chemistry up. It's just that's what I teach for 8, or what I've taught for 8 years. We typically multiply. We don't use the unit conversion guide a whole lot because we're only dealing with milli and kilometer, or a kilo and milli mostly. Okay, so let's look at this one. This is, wink, wink, wink. And if you're not sure what I mean when I say wink, if we were in class, I might emphasize by winking or saying that this is an important question. So if you ever hear me say wink, wink, I'm just saying this is a good type of question. I want you to convert from meters to kilometers or kilometers. So my number, 7,236.4 meters, our base unit. I want to go to kilometers. Now you can think about this a little logically before you even begin. And again, this just comes from my personal experience. I know that 1,000 meters is a kilometer. So 7,000 meters should be around 7 kilometers, right? So 7,200, I have an idea that this is going to be, 7.2, roughly 7.2 kilometers, sorry. But you don't need to know that. You can use the guide here. We're going to go 1, 2, 3. So I go 3 spaces to the left. And as usual, I'll put it here because the number line, I think the PDF kind of shifted some things. So 1, 2, 3. I don't need to add any zeros or anything like that. So my answer is here, 7.2364 kilometers. I'm going to keep all my numbers. You don't need to round anything. You can if you want to. I'm not going to be picky about rounding, but I don't need to do anything else with this number. If you are more of a math type person, you don't want to use the guide. Well, I moved 3 spaces left. So I'm going to divide, and I'm going to divide it by 10 3 times, 10, 10, 10, which is 1,000. Okay, and I will talk about the division in a little later. I'm going to show you something today called dimensional analysis, which sounds really complicated. It's not. So let's look at a few of these. Again, I'll just do maybe 3 of these. And just remember the practice part of this course, or sorry, of this workbook is meant for you guys to do on your own. The answers to all of these questions are shared in the Unit 1 folder on D2L. Make sure you know how to find that, because you guys really should be trying or practicing this when you get an opportunity. There's no worksheets. All of the workbook itself is meant for you guys to practice. All right, so let's look at number 1, number 5, and I guess number 3. So number 1, 46 millimeters to meters. So if I erase my writing, let me just kind of get rid of all this. Okay, so 46 millimeters. Millimeters is up here. I'm up on the number line and I'm going to meters. So I'm going 1, 2, 3 spaces left. 3 spaces left. So 46. The number 46 implies, and what I mean by implies is it's assumed, it's a given that the decimal is at the end of the number. So I'm going to go 1, 2, 3. Now there's an empty space there, so I put a 0. So my answer is 0.046 meters. And again, that makes sense. Milliliters or millimeters, sorry, is such a small number. So the meters should be really small. Okay, well, how do I do this? Okay, I'll try my best to erase this. I'm sorry. My eraser in Adobe is so small. Part of me loves Adobe, part of me hates it. There's no program that's perfect. So let's look at number 3. 4.6 meters, 2 kilometers. Now we basically already did this one. I'm going to go 1, 2, 3 spaces to the left. So I do the same thing here. 4.6 meters. 1. Now look at this. So 2, 3. I'm going to have to add 2 zeros there. Whoops, sorry about that. My wrist hit the keyboard. 0.0046 kilometers. All right, let's look at the last one, number 5. Again, you guys should definitely make sure you practice some of this. So we are going from grams. Now I know that this number line says meters, but this is just a base unit. So this could be grams, this could be meters. What was the other one? This could be, what was it, grams? Oh, liters, L. In this case, I'm using grams. So I'm here at the base unit of grams, and I'm gonna go 1, 2 to the right to turn it into centimeters. So 0.02 grams, I'm gonna go 1, 2. That means it's just 2 centigrams. You could also multiply this by 100. Again, I'm moving 2 to the right, multiply by 100. And this is the point in the class where I lost my recording, which means I asked you guys to practice this. So you're definitely more than welcome or encouraged to practice some of these and check the answers online or on the D2L. Okay, so now let's look at time. And time is a conversion for everybody. My business students, you guys might not deal with meters, liters, grams, but you know, everybody deals with time. Seconds, minutes, hours, and days. So let's look at this. There's 2 things I want to look at. I want to look at time, and then this concept of what we would call dimensional analysis, which in math, they tend to call it unit cancellation. Between us, I don't know if I agree with that. We would call it in science dimensional analysis, but maybe that's making it extra complicated for no reason. I'm going to show you how to convert units or convert numbers by canceling the unit. So let's look at time, we'll look at unit cancellation, and then we'll do some examples. And some of these examples get a little complicated. This is the end of the topic, so I'm going to show you some of these, and then I'll stop here at topic 4, which will bring me to Thursday's class. Okay, so let's talk about first time. All right, so in Math 1700, we're going to convert with, or we're going to concentrate or look at time conversions in a kind of a smaller way. We're not going to deal with months or years. We're going to look at seconds, minutes, hours, and days. And the reason I'm bringing that up is I have taught business math before. So, depending on what you do, I think most of you guys would be probably doing maybe engineering or medical science, but anybody else might deal with weeks, months, years, but we're going to keep it kind of simplified: seconds, minutes, hours, and days. Now, there's 2 ways to look at time. You can use the unit cancellation method down here, which is what I typically do, and I'll certainly show you that in a few moments. But there is kind of a little shortcut. The thing about time is you need to remember certain things. Most of you in your everyday life, you should know. I hope you know, and again, if not, don't worry, but you should know that there are 60 seconds in a minute. There are 60 minutes in an hour. There are 24 hours in a day. And there are, if we went larger, 7 days in a week, and, think 52 weeks in a year, things like that. So there is a quick way to do this. If you were going to go from seconds to minutes, you could divide by 60. Minutes to hours, divide by 60 again. Hours to days, divide by 24. So we're going from a smaller unit, seconds, for example, to a bigger unit, minutes. We again divide. You can't move the decimal place because time conversion doesn't follow the metric system. Seconds is a SI unit. So seconds is a unit of measurement in the metric system, or I should say the SI system, but it's not a metric conversion. So we can't use a factor of 10. And because we can't use a factor of 10, we can't use or move the decimal place. We can't use the method of multiplying by tens or moving the decimal. So a little bit of memorization involved with this. Now, if we're going from a larger unit, like let's say days to hours, a larger unit to a smaller unit, you would multiply. So days to hours is 24, multiply. Hours to minutes, you would multiply by 60, and minutes to seconds, multiply by 60 again. When you get into something like milliseconds, you are actually using the metric system, but that's not for this course. So we'll talk a little bit about time in a minute. The next part is unit cancellation, which I alluded to as something we call in science dimensional analysis, using a conversion factor, a fraction basically, to cancel units to get the unit we're looking for. So there are steps here to solve this, but I think I'm basically going to show you how it's done. Step A, consider the relationship between your numbers. So the original question at the top of this is, how many kilograms are in 1,500 grams? First thing you do, think about how many kilograms are equivalent to grams, or what's the relationship? So I know that 1 kilogram is 1,000 grams. Step B, this is a little different than how I typically do it. I typically kind of go to step E here, but step B is to divide both sides of this equation by 1,000 grams. Between us, step B and C, and even D, I wouldn't really worry too much about. Step C says, show how the value is equal to 1. This is kind of where what I'm talking about with a conversion factor. Um, Step B is kind of the theory behind this, but the idea is 1 kilogram is equal to 1,000 grams. And like when I say equal, like they are exactly equal. 1 kilogram is literally 1,000 grams. And that becomes important a little later in your math journey if you convert, say, something like grams to ounces or inches to meters. It's an approximation typically, it's not exact. And again, the beauty of the metric system is this is exact. So 1 kilogram is exactly 1,000 grams. So what you would do in step E, which is kind of where I would start with this after step 1, is I would take my grams, my 1,536 grams, and I would multiply it by that conversion factor. And what I'm doing is again, sorry, this is called, or this is what I'm calling the conversion factor. By that, I mean, conversion fraction. What you're looking for is for your units to cancel. When a unit is on the top and bottom of a fraction, we would call this the numerator and denominator. Talk about that later. They cancel. So because the grams cancel, I'm left with kilograms, right? You can see that here in step F. The grams cancel, I'm left with kilograms. So essentially, I'm dividing this number by 1,000 and I get my answer. One, is that right? I feel like there's a little typo here. There's totally a little typo here. And I didn't notice that when I taught that. But when you divide this by 1,000, you would get 1.536 kilograms, okay? If that's confusing, don't worry, I'm gonna show you. So there's 3 examples here. Let's look at those. Then I'm gonna look at this one. This one, very difficult. And then maybe I'll do a couple practice ones, and that's it for this recording, okay? All right, so the examples obviously start from, pretty easy with the time conversions. Just note that these examples are using unit cancellation, not like the kind of easy, I don't want to say easy method, but not just kind of, multiplying by 60. We're going to look at the units and how they cancel. And then we're going to talk a little bit more about combining these conversions. So changing like from meters to kilometers and then seconds to hours in the one thing. And, I just mentioned it, this looks crazy, but kind of, don't worry too much about it. It's pretty straightforward once you practice. So looking at time, convert 40 minutes to seconds. Now, I really want you guys to think, like, don't think about Math 1700. Think about if somebody, gave you a pen and paper or a calculator and said, how many seconds would be in 40 minutes? And imagine you've never come to math class. This was, last semester or something. What would you do? 40 minutes to seconds. Well, hopefully you would think about how many seconds were in a minute. And the answer is obviously 60. So if 1 minute is 60 seconds, 40 minutes would be 40 times 60, right? Again, like 1 is 60, so 40, we would multiply that by 60. The unit cancellation method is to use, again, I'm going to call this the conversion factor. I know that 1 minute equals 60 seconds, and I'm going to turn that into a fraction. And I'm going to organize my fraction, the top and the bottom. The numerator is the top, the denominator is the bottom. I'm going to organize that so that my units cancel. I'm trying to convert change minutes into seconds. I want minutes to go away and I want seconds to remain, which you can see here. So again, remember if the unit is on the top and the bottom, they cancel each other out. You know, a minute divided by a minute is just one. So the unit minute just kind of goes away. It turns into one. So 40 minutes turned into seconds. I'm just multiplying 40 by 60 and I get 2,400 seconds. Makes sense. Another thing I want to mention is think about your numbers logically. What I mean is 40 minutes into seconds, the answer has to be big, right? Hold on, just 1 second. I'm just plugging in the computer here. 1 second, guys. The battery is getting low, so let me plug this in. Okay, hold on. Okay, sorry. Think about the number. 40 minutes into seconds, your answer has to be bigger, right? There's more seconds, or seconds is kind of like, well, a smaller unit, so your answer should be a bigger number. I hope that makes sense. It's kind of a weird thing to say. A smaller unit makes a bigger number, but the idea is 40 minutes is a unit of time to measure something a little larger than a second. So the answer is quite large, 2,400 seconds. The next one, pretty straightforward. I want to convert 1,200 hours to days. Okay, so I'm doing number 2. Well, I know that 1 day is equal to 24 hours. So that's my conversion factor, which I turn into a fraction. And I make sure that the hours are on the bottom in my conversion factor, in my fraction, so the hours cancel. So I'm going from a smaller unit to a bigger unit. The number should decrease. There's less days. Numerically, there's less days here. So the answer, when you take 1,200 and divide by 24, you get 50. This is a good one because we're going to go through 2 units here. Convert, and there's a little typo here, which I'll fix. You'll notice that these numbers aren't the same. That's a typo or a mistake in the user guide. So let's just fix that. Hold on. So convert 14,400 seconds into hours. The issue with this is there's no direct way. If you look at the page above, there's no direct number or method to do this conversion. I need to do this in 2 steps. 600 seconds to hours. So what I want to do is change the seconds to minutes, then change the minutes to hours, because I know that there's 60 seconds in a minute, and I know there's 60 minutes in an hour. So this, I need to do 2 conversions. Again, I'm just gonna like make a little note here, 1 minute equals 60 seconds. I know that 1 hour equals 60 minutes. So these are the fractions I'm gonna use. I multiply them. I make sure my units cancel. So 14,400 seconds. First, I multiply it to turn it into minutes. 1 minute over 60 seconds. Then I want to get rid of the minutes. So I multiply it a second time by the other factor, 1 hour over 60, and I get the answer of 4. So mathematically, on a calculator, I'm dividing this number by 60 2 times. Let me clean this up a little bit. So I'm taking 14,400 seconds and essentially multiplying it by 1 over 60 twice. Mathematically, we would say that we're dividing it by 62 times. And I get 4. Okay, sorry. I don't have my calculator here. But I'll go grab it in a minute. But yeah, I think this is correct. Well, let me check because I know there's a typo here. I want to make sure everything is okay with the answer. So I'm going to divide it on my calculator by 62 times. Yeah, 4 hours. Perfect. Now, this is the last topic of tonight, and this gets a little bit complicated because area, well, or more specifically in this type of calculation, the volume is a special type of unit. Area would typically, for a rectangle, be length times width. For a circle, it's a little different. Volume is typically length times width times height, or the area of the base times the height. Again, we're speaking very generally here. We're talking about rectangles or cubes. One thing to remember is that a cube, or sorry, the volume is what we would call a cubic measurement. The units are cubed. And to do this conversion, we have to be careful. If I'm trying to convert, for example, centimeters cubed, so I'm converting centimeters 3 times. We'll talk a little, well, you guys would have seen this because I'm re-recording this session, but the exponent 3 means cubed. I'm going to need to cancel that unit 3 times. So I'm going to, you'll see, I'm going to go through these examples and then we'll do a couple practice. For example, 2 and 3, I'm actually going to do those in PowerPoint because they're so kind of, I don't want to say complicated, but there's so much going on there. Question number 1 is actually quite simple. We've already done a question like question number 1. So just give me a second. Well, okay, let's do number 1. And then just give me a second to open up PowerPoint and we'll do the next 2. Question number 1, very simple because we are just going from milliliters, the prefix milli, to liters. And I know my conversion factor, my relationship between milliliters and liters. I know that there's 1,000 milliliters in 1 liter. So to convert from 50 milliliters to liters, I turn that into a fraction and I make sure that the milliliters are on the bottom, what we would call the denominator, to make them cancel. So 50 divided by 1,000, I would get my answer 0.05 liters. You could use, that, I keep saying number line, the unit conversion line to do this one. You would move the decimal place 3 to the left. Sorry, that's an L there. Oh, sorry. My screen is really small, so it's hard to write there. So excuse my messy writing. Questions number 2 and 3 are much more involved. It's like look at number 2, look at number 3. So just give me a second. I'm going to do these where I have more space to write in PowerPoint. And then I might do a couple of these, maybe just 1 or 2 of these for practice. And that's it for this lesson. All right. So I'll just be right back. I'm going to open PowerPoint. All right. So the first, well, it's question number 2 in the examples. You'll notice, like, obviously the screen's just a big blank white screen, and I do this because I have so much room to write, and it's really easy to erase, as you can see. The first question, or the second question, is 38.2 meters per second. And I'm trying to change it to kilometers per hour. So the first part of this question is quite simple. Well, I shouldn't, I hate saying that it's simple, but it's, putting this question together it looks challenging, but changing meters to kilometers, we should be fairly confident or comfortable with this. I can move the decimal place 3 to the left, or divide it by 1,000. Basically, what I'm going to do is on the right side of my screen here is make a list of my conversion factors. So I know I want to go from meters to kilometers. And I know that there's 1,000 meters in 1 kilometer. So that will take care of my kilometers. Seconds to hours is a little bit more trouble, because again, to get to hours, I need to go through minutes. So I know that there are 60 seconds in 1 minute. And I know that there are 60 minutes in 1 hour. So using all of this information, I should be able to solve this question. Just remember, the way that I organize my fractions is so that the units cancel. The units must be on the top and the bottom to cancel. So I mean, the notes do this all in one big step, which I guess I'll do because, it's pretty straight. Well, no, it's not straightforward, but it's pretty convenient, I guess, to do this all in one big step. So first things first, I'm going to multiply this by my first conversion factor to change it into kilometers. I want the kilometers on top and the meters on bottom. And that way my meters will cancel, leaving me with kilometers. So that part's done. If this was a test question, you would get, a mark for that. The next part is I need to look at my seconds. So then I would multiply this by 1, oh, sorry, and you'll see why I'm writing it like this. 60 seconds over 1 minute. My seconds will cancel, but I'm not done because I need to convert this into hours. So I'm going to multiply this by 60 minutes over 1 hour, and then my minutes will cancel. And you should notice what's left, what hasn't been canceled: my kilometers and my hours. So I got my calculator. So 38.2, I'm going to divide it by 1,000. I'm going to multiply it by 60 twice, and I'll get my answer as 137.52 kilometers per hour. So, if this was a car, you would be going pretty fast. You guys can probably picture this in your head. The speed limit in Qatar on like the expressways or highways are typically 100, 120, so pretty fast. Now, one thing I want to mention before I move on to the second example is this conversion factor comes from this, and I put my meters on the bottom to cancel. The second conversion factor comes from this, and I put my minutes on the bottom and my seconds on the top so that the seconds will cancel. My third and final conversion factor, I'm running out of easy colors here. Sorry, that's a bit dark, but that's all I can do, is my conversion to hours. So there you go. And personally, I think that looks a little bit easier than what's in your booklet. Okay, so take a minute. You might have to pause the video, let that sink in. I'm going to clear my screen and I'll do the next example, which in your notes is example number 3. This example would be example number 2. All right, let's look at example number 3. Example number 3 is taking, and I really want you to pay close attention to this one, 575 grams per centimeters cubed. That means centimeters 3 times, and we're going to convert it to kilograms. Again, a pretty easy conversion there, to meters cubed. So there's really only two conversions I'm doing here. I know that 1,000 grams is equal to 1 kilogram. And I also know that 100 centimeters is equal to 1 meter. The challenge or the issue with this question is that the centimeters and meters are cubed. We talked about this in Wednesday's class. Again, I'm kind of talking about the future. Cubed means to the power of 3. So let's start with the kilograms. So 575 grams, centimeters cubed. Step number 1, I'm going to multiply this by 1 kilogram is equal to 1,000 grams. And again, my grams will cancel. Perfect. You know, I said this in the last question. If this is on a test, you get a mark. Now, the centimeters cubed, I want to change that to meters. So, you know, I have my 1 meter on the bottom and I have my 100 centimeters on top. But the thing is, I need to cube or raise these numbers to the power of 3. And this is a button on your calculator. If you have a Casio calculator, you will find the exponent button. So like this is my calculator button, it would look like this. And this would let me put a number, what we would call to the exponent 3 or to the power of 3. If this doesn't make any sense, well, I shouldn't say don't worry, but maybe watch the fourth class, the fourth class, Wednesday's class. Meaning go to the next class and you'll see a lot more about exponents. Okay, so I put this in on my calculator. I'm going to do this now. So 575 divided by 1,000. And then I'm going to multiply it by 100 3 times, or more specifically, 100 to the power of 3. And I got a really big number here. 575,000. This would be kilograms per meters cubed. The centimeters cubed will cancel. And using the highlighter like I did last time, this conversion factor is here. I put the grams on the bottom so that the grams cancel. And this conversion factor is here. Putting the centimeters on top this time so that they cancel with the original question. Definitely not the easiest thing. You'll see, like again, in lesson 4 and lesson 5, we'll kind of get into more mathematical things than unit conversion, but definitely useful to know, definitely a little challenging, but worth practicing. So let me just show you maybe 1 or 2 more, and then that's it for this topic. If you guys have any questions, as always, come find me. Attend my office hours, send me an email, and we can go through this. Okay, so I'm obviously back into the course notes. Oops, sorry about that. You'll notice the answer for question 3 has like a little, well, it has the answer that I mentioned right here, right? But it does have this. This answer is, depending on your calculator or the settings on your calculator, this answer is what your calculator might say. This is something called scientific notation. Sorry about my spelling. We'll kind of cover, or we'll talk a little bit more later about scientific notation. Most of you will do this in physics or chemistry as well. For the any students not in physics or chemistry, Not necessarily a big deal. What I really want to emphasize or stress to you is, whatever your calculator gives you, and I mentioned this in the next topic that I did today, just trust your calculator. Be careful, put your numbers in correctly, use brackets, use the negatives, use the exponent button. But if your calculator said something like this, your calculator might also, depending on the brand, say something like this. This would be if you had like a Texas Instruments graphing calculator, like the 83 or 84. Um, Trust your calculator, and we'll talk a little bit more about scientific notation. That's not really the focus of today. So, for all intents and purposes, this is your answer, right? Oops, sorry. Sorry. Right here, sorry. Apparently, Adobe doesn't let me undo things or redo things. Well, we're nearing the end of this lesson. This is one of the hardest lessons we've done in the first week, or um, maybe most challenging. But let's look at maybe questions 1 and 2, and then of course these other questions are there for you to practice. As I mentioned earlier, the answers to these questions are shared on the D2L under Unit 1 Solutions. So you can find that on your content page on D2L under Unit 1. So you guys definitely, I highly recommend you practice all of these. They're very, very good for practice. So let me just do 2 more, and then halas, we're finished. And that'll be it for this lesson that I unfortunately didn't record. All right, I'm going to zoom in a little bit and kind of do this like I did the other questions. So question number 1 and 2, starting with number 1. First things first, consider the conversions we're dealing with. I'm going from 50 milliliters per minute to liters per hour. So I need to go from milliliters to liters, and I need to go from minutes to hours. Sorry about my screen there. I don't know what's going on. Pretty straightforward. There's 2 conversions here. So 50 milliliters per minute. First thing I'm going to do is change my milliliters to liters. So 1 liter over 1,000 milliliters. And the reason I do it like this, the reason I set up my fraction like this, is to get the milliliters to cancel. Something I never really mentioned, but I've been kind of hinting at it or assuming you knew this, these fractions can be reversed or flipped. So you organize them based on the question. I am choosing to put liters on top and milliliters on bottom. It's a choice. You can flip it. You can have milliliters on top or liters on top, whatever you want. And the reason I picked this way is to get the milliliters to cancel. Next, I'm going, so that's it. That's to change the milliliters to liters. And then next, I'm going to multiply it by 60 minutes over 1 hour. Oops, sorry, to get my minutes to cancel. So again, I'm going to use my calculator for this. 50, I'm going to divide it by 1,000 and multiply it by 60, and I get a nice answer, 3 liters per hour. All right, and again, I'm circling the units that we're left with. I didn't cancel liters, I didn't cancel hours, everything checks out. For any students moving into physics, you're going to see this and you're going to use this method. Sorry about this. 2 I'm not going to do because 2 we already did above. It's just like an oversight, or I guess you could call it a typo or a mistake. We already did question 2 above. So let's do, instead of 2, let's do number 3. Again, number 2, we already did. I did that on my PowerPoint. So I want to change 200 millimeters per second to meters per second. This is a pretty good one. 200 millimeters, well, I know I need to change millimeters to meters. So I know that there's 1,000 millimeters in 1 meter. And I'm going from seconds to seconds, so I don't need to worry about that. This is actually a pretty easy one. Oops. So 200 millimeters per second. I'm going to multiply this by 1 meter over 1,000 millimeters, which cancel. So this ends up being 0.2 meters per second. All right. So guys, I'm going to end it here. Definitely try these examples. You'll notice some of these you're going to have to use, well, let's do number 7. I guess I don't need to end it right now. I have infinite time, I guess, don't I? You're going to have to use units maybe more than once. So let's look at number 7 before I actually finish. I'm going from grams per centimeters squared, which is to the power of 2, to kilograms per millimeter squared. Ooh, this is interesting. This is a good one to actually finish on. So first things first, I know that there's 1,000 grams in 1 kilogram. And I also know that there is 10 millimeters in 1 centimeter. Okay, 10 millimeters makes 1 centimeter. So what I'm going to do is put these fractions in. I'm going to be careful about the squared, and we're going to solve this question. Okay, so first things first. I think I say that a lot, first thing first. But what I mean is, the first thing I'm going to do, and this is kind of repetitive. We're doing this in most questions, changing the numerator unit, the top unit, to something simple. We've done this before or earlier today or tonight for me. So all I'm going to do is change this to kilograms. So I multiply it by my conversion factor. Grams cancel. Again, we've done this enough times, pretty straightforward. The challenge to this question is getting rid of that centimeters squared. Okay. One thing I'll mention too is, I can't seem to get that X right. When I say the word squared, in math, we mean, something to the power of 2. When I say cubed, I mean something to the power of 3. When I say something, I just mean, any number. So I'm using the letter A to represent that. It's what we would call a variable. And I'll talk more about variables in the next class. But squared means a number to the power of 2. And cubed means a number to the power of 3. You can think of a square having 2 sides, a cube having 3, I don't want to say sides, but a square has 2 sides, length times width, and a cube has 3 sides, length times width times height. Or I guess sides isn't the right word. I should say dimensions. So 2 dimensions and 3 dimensions. This is definitely something we'll talk about a little later. So what we have to be careful with here is I need to change my centimeters squared into millimeters squared. So what I do is I also square these numbers. And again, this is done on your calculator with, like I mentioned, your square button, which on a Casio, by the way, is the brand name, like Sony or Samsung. Casio would be the calculators we typically use at the college. The button would look like this. Okay, so let's check out our answer, and then that's it for me. 7.45, I'm going to divide that by 1,000 to get my kilograms. And then I'm going to divide it by 10 squared, or 10 times 10, which we're going to talk more about the squared ideas tomorrow. So actually, my calculator gives me an interesting answer. I get 7.45 times 10. Oh, sorry. Let me get rid of this line here. 7.45 times 10 to the negative 5. My units would be kilograms per millimeter. This, again, I've mentioned this earlier. This is what my calculator is giving me, which is totally okay, totally perfect for a test question. This would actually be 0.0000745 if we turned it into a decimal. We'll talk a little bit about this later, this concept of scientific notation. And you guys and anybody who needs this, or you want to know more about this, you'll see this a lot more in your chemistry and physics. And if you're not doing chemistry and physics, then scientific notation is not really something you would worry about. 1, 2, 3, 4. 1, 2, 3. Yeah, okay. Just making sure I did that correct. So guys, that's it for me. Remember, try these questions, practice them, look at the answers on your D2L. Hopefully I won't make this mistake again, and I will actually record my classes, but that's it for me. So I'll see you guys in the next day or next class. Thank you so much. Take care. Be safe. Wear a mask. Wash your hands. Bye-bye.